I think time is running out for lunch. I'll keep it short. So I'm going to talk about something little different, but in the same context of what other speakers have been talking about. Because we're a small company, our focus is not that diverse, and we're really focusing on making your IoT engineering easy. So when I looked at the IoT engineering in probably back in 2012 when he started this, I said, what we're doing here in the IoT, because connected device existed for such a long time. Then it turns out the only thing that we can do better is probably make it more cheaper, scalable, and make it easy. Now, cheaper and scalable, I would say the scalable part is more in open source, cheaper part is in the hand of silicon device manufacturer. So, as a system engineering point of view, what we can do is make it life easier. And how we do that? So, I can spend probably 2 hours on the whole thing. And this is also very standard. I'm not doing anything new, but I'll show you that we did a little bit of twist and tweak and a little bit of patented innovation here and there to make your life a lot more easier. So I'll start actually from backward side, which is data visualization layer. So in data visualization layer, if you talk about any platform in IoT, they'll talk about analytic data, historical data, MRO, which is what it links with the ERP systems. But what we added is another layer called fuel gauge visualization, and I'll come back to that, and we put more learning program into that. And the idea is when we go to Midwest, most of the maintenance people are actually farm boys. They don't have even high secondary school education. So how do you make this data available to them and they can react to the machine? And I'll do a little more details on that. On the server layer side, if you look at you probably have to look at here. On the data queuing, stitching, getting ready for viewing, or metadatabase, or time series and data compression, all of it is available today in most of the platform. Again, what we did new is to add a IoT simulator layer, because we figured out that both real time and non-real time is important. Real time is good, it's for production, but off real time is also important because we use a lot of advanced learning algorithm. We are using deep learning, we are using field learning. And if you want to use advanced learning algorithm, you must have a data replay capability. Not only a replay capability, it comes with a lot of complexity to use those data so that you can test those advanced algorithms behind the production, and at some point you can upgrade to the production. Because most of the data you cannot get offline. You get it on the field, and if you get into the field, you have to do both simultaneously, otherwise there is no practical advanced solution. On mobile middleware layer, again, system calibration, sensor calibration, analytic model calibration, or system baselining, then asset management that Shalini talked about, we do all. But again, with a slight tweak, addressing some key pain point. That is, on model calibration, system calibration, and sensor calibration, it has to be a single stack instead of a different stack. And there is a lot of benefit to that, and that's our patented stuff, because we figured out that if you're really talking about advanced sensor data, we need to put the three stack together. On hardware layer, we have not really innovated much, except that we use a standard stuff. But again, there are scope of innovation, but perhaps not that important at this point. Now, as I said, we want to make your life easy. And it is not about only software, electronics, or anything. It should start right from the mechanical engineering. I worked as a sensor engineer for longer than anybody actually here, and I know, because I have installed so many sensors in the industry, the biggest pain in sensor is in the machine. Because when you do the mechanical engineering, there are different kind of machine. How I'm going to fit my sensor? That's the first question. I can have one single electronics. So we come up with the concept of machine wearable sensor. You can visit our booth and see we have a modular concept. We have a concept of magnetic holding, so that you can go and snap on. And basically, it has to be also multi-purpose sensor, can be used from for different parameters, because if you can't do that, then you need too many sensors, means too many data. Don't work that way. You have to really integrate. Again, addition, decodification, calibration have to be in a single mobile layer. And this is again not something new. Only new thing is basically on our last part, the way we link our model calibration with the sensor calibration data, and it is extremely important. Probably 20 minutes is not a good time. If you have any time, I can talk later, because this is we learned from our experience. Okay. And now come to the point probably most of you are actually, might be noticing that we use a lot of what you call fuel gauge. Fuel gauge is nothing but, I figured out in United States, everybody understands their car condition from a fuel gauge, right? So even if the farm boys, everybody can understand what is good and bad about the machine condition. So the challenge is, I get a 3-axis vibration data, and how do I transform into a very simple gauge that people can all the time monitor and do that? In order to do that, it's not really very easy. Actually, the viewing might be easy, but behind you have to really do a lot of signal processing, a lot of learning, and of course, it has to be combined very well before you can deliver into that kind of format. So there are 3 stages of stage-by-stage learning that goes into it before you can deliver this kind of easy view of the system. In server data side, again, this is very standard. I'll claim nothing new. Everybody these days are using Cassandra for the time series, Apache Spark for analytic, and mostly Kafka for stitching it together. So nothing new here. Now this is the part that is new in IoT simulator. So this is basically the offline and the backend architecture that we use to develop more advanced learning algorithm. What we do here is that basically we have the idea of the recycling of the data all the time. So on one side, we know what the production algorithm is given. On the backend side, we know that the production algorithm is failing sometime. We have a fairly good concept of that, why it is failing. We basically can now pour all those data into the simulator to figure out on the backend why something is failing, and we can and our engineer can offline improve their algorithm, run it to improve it right there, and can stitch it there. And this kind of capability is absolutely must if you are talking about industrial IoT, because you cannot get data offline. Yeah, so this I already talked about. So we have some demo of the, if you really want a demo of IoT simulation, I will not rather waste our time. We just open our office in Bangalore. You can go to our booth and fix up your time. Maybe in the month of January, you can come and see how the whole system is running. We are fairly comfortable because much of it is already patented. You can please come and see if you see if that is useful. Now, in terms of the visualization, and this is very interesting because every easy thing actually should be in the visualization. So I was inspired by a paper in IEEE, and they call about 5W visualization in the mobile. Again, I can spend 1 hour on that, but let's say on the model of how, why, what, when, and where, I focused on who primarily because I need to know who are intended user of my analytic data. If you go data that only engineer understand, then the viability of the solution is very restricted. So we have a defined layer of filtering for maintenance personnel, engineers, and managers. They will have a very defined view of the analytic of the same data. I'll skip that. Probably not that much of importance because I'm going to give you 2 examples of what we did. Everybody knows why mentioned downtime is dangerous, but so far we did a lot of research from our OEM partners of a different kind of machinery fault like imbalance, bend sharp, eccentricity, cavitation, electrical faults, rotor rub, resonance. And when you use multi-classification algorithm, these are the classification, this all belongs to some kind of class with some kind of intensity to separate out as a gauge value so that people can understand much more easily. Again, I'll skip it. If you want to see the demo, it's really not important here, but you can come and see. But basic concept of any kind of machinery failure or predictive maintenance is that you need to have a good baseline of the good machine. Because keep it in mind, much of it is supervised learning. Well, it can be unsupervised learning as well, but let's not get into that. I would say that predominantly it's a supervised learning. In a supervised learning situation, you need to know what is a good machine versus bad machine, which means you really need to know a baseline, means a good machine conditions should be guided to tell you the classification is right or wrong. Okay. And once you do the classification, the greatest thing is that you get an MRO log, which means, I will be able to predict in how many days your filter is getting wrong, in how many days your bearing is getting wrong, whether your temperature is good and bad, and all of this log should be integrated with any kind of manufacturing ERP system. So what you do is that we give a very simple API to get all those logs, and you can import into your ERP system. And then second example I'm going to give it because I think you're all fed up with a lot of example of predictive maintenance, although we also do that as a most and practical example. We are doing another thing probably you have not heard of, that is electrical line diagnosis. And electrical problems is very severe, especially in a country like India. Probably everybody have seen the sags, swells, voltage dips, voltage goes up, lot of harmonics, because not a single building you can find here which has a good grounding and all sort of stuff. And here again we apply the same philosophy, and we have a very simple snap-on sensor, have a data hub sending the data to the cloud, and finally we want to give a very simple visualization of how good or how bad is your electrical condition. And then of course what I am not showing here is that on top of that we have a lot of analytical layers in which we can do some very specific targeting problem solution, like whether you have a grounding problem, or for example I have an industrial dryer client where they want that heater condition should be predicted much in advance. We have a much easier solution to do that as well, but anyhow it's based on the same combined architecture that I have shown you. So thank you. I hope I have been able to make it within 10 minutes. Thank you. Now any question please. But in any case, I know that this is so deep, it doesn't matter, 10 minutes or 20 minutes won't make a difference. What makes a difference is that if you're really interested, we just started a lab in Bangalore, so we'll be able to give you a demo. You can come our booth, request for a demo, and perhaps we can have a more involving discussion. Okay? So any question please. Any question? No, we're fine. Sure.
I have just very simple
Sure.
question. How is it different from condition monitoring? This has been existing since I mean, for last 20 years, a lot of people have been doing work on condition monitoring, especially in factories.
No, absolutely you're correct. As I said, there is nothing new in IoT. It is the way you do it.
Okay.
So the way we are doing it is basically, in this case, I can, let's say your manufacturing plant have 100 machines. Okay. You want to monitor that, right? The difference is right now I can plug in my sensor at a very low cost, and all the 100 sensors are sending me data 24/7. I am getting all this conditioning monitoring 24/7, and right away anything happening, you are getting it into your hand. So the question is, what you are doing new, my answer always will be is the way we are doing it, which is cost effective, much more scalable, and doing it in much more real time. Otherwise, I would say most of the concepts we are doing it, if I did the history of manufacturing, many of the concepts already existed.
And what about vibration signature? Do you monitor vibration signatures for rotating equipments? Vibrations signatures?
That's what we do, right? So basically how I'm telling that there is a high oil viscosity problem or bearing problem, it is because I'm catching the signature of the vibration, and that is being done for last 30 years. So you can say what is new in it, right? And that is the question I have to answer all the time. The answer to that your question is there are a lot of things new. One of the things is that we have a couple of proprietary patents I can send you to read. Your data, when it is leaving the sensor, has to be extremely light before it travels to any kind of wireless network. Otherwise, I won't be able to do it in a single thing. So we have to do a lot of analytic processing inside the electronics before it leave it. And not only that, right now, if you go to any kind of vibration analysis companies, which are our actually competitors, they actually take the data and then they will analyze by an expert. There are a lot of other kind of stuff. There are harmonic analysis and many other kind of stuff. But in our case, we have to use a very defined kind of data science to make it real time. Not only real time, it will be both real time or non-real time. So the way we are doing the data science, the way we are collecting the data in electronics is entirely different. Even if I'll be the first person to say the vibration analysis existed in the industry for the last 30 years, and it was great. Only problem is it is not real time and it is very expensive. That's all.
Thank you.